Overfitting is a common challenge in the field of data science, where a machine learning model performs well on the training data but fails to generalize well on new and unseen data. This phenomenon occurs when the model becomes overly complex and starts to memorize the training data instead of learning patterns and relationships. To avoid overfitting in data science, there are several techniques that can be employed. 1. Cross-validation. Cross-validation is a widely used technique to assess the performance of a model. It involves dividing the data into multiple subsets, training the model on one subset, and testing it on the others. By repeating this process multiple times, one can get a more reliable estimate of the model's performance. 2. Regularization. Regularization is a technique used to prevent overfitting by adding a penalty term to the model's objective function. This penalty term discourages the model from fitting the noise in the training data and encourages it to generalize better on unseen data. Common regularization techniques include L1, Lasso, and L2, Ridge. Regularization. 3. Feature selection. It is important to select the most relevant features for your model. Including too many features, especially those that are irrelevant or noisy, can lead to overfitting. Feature selection techniques such as forward selection, backward elimination, and regularization can help identify the most informative features. 4. Increasing the training set size. Overfitting often occurs when the model has too little data to learn from. By increasing the size of the training set, the model is exposed to a wider range of examples, making it less likely to memorize the training data. 5. Ensemble methods. Ensemble methods, such as random forests and gradient boosting, combine multiple models to make predictions. These methods reduce the risk of overfitting by averaging out the predictions of individual models, resulting in a more generalized and robust model. 6. Early stopping. This technique involves monitoring the model's performance on a validation set while training. If the model's performance starts to degrade on the validation set, training is stopped early to prevent overfitting. In conclusion, avoiding overfitting is crucial for building reliable and accurate data science models. By employing techniques such as cross-validation, regularization, feature selection, increasing the training set size, ensemble methods, and early stopping, one can mitigate the risk of overfitting and create models that generalize well on unseen data. Thank you for watching. If you enjoyed this video and found it helpful, don't forget to hit the subscribe button and turn on the notification bell.